An arc fault circuit interrupter, or AFCI, is a type of circuit breaker designed to protect against electrical fires caused by arc faults. These arc faults are unintentional electrical discharges that occur where electricity jumps between two conductors, often due to damaged or deteriorated wiring. The AFCI breaker is designed to detect these arc faults by analyzing the current flow and identifying unusual patterns characteristic of arcing. When an arc fault is detected, the AFCI breaker quickly trips, interrupting the flow of electricity and preventing the arc from escalating into a fire. Standard circuit breakers, on the other hand, primarily protect against overloads and short circuits. An overload occurs when a circuit draws more current than it is designed to handle, typically due to too many devices being plugged into the same circuit. A short circuit occurs when there is a direct low-resistance connection between two conductors, causing a large and potentially dangerous current flow. While standard circuit breakers will trip in response to overloads and short circuits, they are not specifically designed to detect and respond to arc faults. This is where AFCI breakers provide an additional layer of protection, particularly in older homes or buildings where wiring may be more susceptible to damage and deterioration. AFCI breakers are now required by electrical codes in many areas for new construction and renovations, particularly in bedrooms and other areas where arc faults are more likely to occur. These requirements reflect the growing recognition of the importance of arc fault protection in preventing electrical fires. Knob and tube wiring is an early standardized method of electrical wiring in buildings common in North America from about 1880 to the 1930s. It consisted of single insulated copper conductors run within wall or ceiling cavities supported by ceramic knobs and tubes. Where wires passed through wood framing members, they were protected by porcelain tubes. The purpose of the knobs and tubes was to maintain an air space around the conductors, providing insulation and allowing for heat dissipation. This method of wiring was considered safe at the time, but it has several inherent limitations and potential hazards by modern standards. One of the main concerns with knob and tube wiring is the aging of the insulation. The original insulation materials used on knob and tube wiring, such as rubber or cloth, can deteriorate over time, becoming brittle and cracked. This deterioration reduces the insulation's effectiveness, increasing the risk of short circuits and arc faults. Furthermore, knob and tube wiring typically lacks a grounding conductor. In modern electrical systems, a grounding conductor provides a lower resistance path for fault currents to flow back to the source, allowing circuit breakers to trip quickly and prevent electrical shock hazard. The absence of a grounding conductor in knob and tube wiring means that fault currents may not be detected quickly, increasing the risk of electrical shock and fire. Another concern is that knob and tube wiring is often overloaded or modified improperly over the years. As electrical demands in homes have increased with the proliferation of electronic devices, homeowners may have attempted to draw more power from existing knob and tube circuits than they were designed to handle. This can lead to overheating of the wires and insulation, increasing the risk of fire. Additionally, improper modifications to knob and tube wiring, such as splicing wires without proper connectors or covering the wiring with insulation, can further compromise its safety. Due to these concerns, knob and tube wiring is generally considered obsolete and potentially hazardous by modern electrical standards. Many insurance companies will not insure homes with active knob and tube wiring, and electrical codes in many areas require that it be replaced or upgraded during renovations. If knob and tube wiring is present in a building, it is recommended that it be inspected by a qualified electrician to assess its condition and determine the appropriate course of action. This may involve replacing the wiring entirely, upgrading the electrical service, or implementing other safety measures to mitigate the risks associated with knob and tube wiring. Compromised polarity refers to a situation where the hot and neutral wires in an electrical circuit are reversed. In a properly wired circuit, the hot wire carries the electrical current from the source to the load, while the neutral wire provides a return path for the current back to the source. The hot wire is typically identified by its black or red insulation, while the neutral wire is identified by its white insulation. When the polarity is compromised, the hot and neutral wires are connected to the wrong terminals. This can occur due to incorrect wiring during installation, damaged wiring, or improper modifications to the electrical system. Compromised polarity can create several safety hazards. Firstly, it can cause electrical devices to become energized even when they are switched off. This is because the switch is typically located on the hot side of the circuit, so when the polarity is reversed, the switch only interrupts the neutral wire, leaving the hot wire connected to the device. This can create a shock hazard if someone touches the device while it is switched off. Secondly, compromised polarity can interfere with the proper operation of ground fault circuit interrupters, or GFCIs. GFCIs are designed to protect against electrical shock by detecting imbalances in the current flowing through the hot and neutral wires. When the polarity is reversed, the GFCI may not be able to detect these imbalances, rendering it ineffective in preventing electrical shock. Thirdly, compromised polarity can increase the risk of electrical fires. This is because the reverse polarity can cause overheating of electrical components and wiring, increasing the likelihood of a fire. It is important to note that compromised polarity may not always be immediately obvious. Electrical devices may still function even with reverse polarity, but the underlying safety hazards remain. Therefore, it is crucial to have electrical systems inspected by a qualified electrician to ensure that the polarity is correct and that all wiring is safe and up to code. If compromised polarity is detected, it should be corrected immediately to prevent potential electrical hazards. This typically involves rewiring the affected circuits to ensure that the hot and neutral wires are connected to the correct terminals. AFCI breakers are designed to detect arc faults, which are unintentional electrical discharges that can occur in damaged or deteriorated wiring. These arc faults can generate heat and ignite nearby combustible materials, leading to electrical fires. AFCI breakers work by monitoring the electrical current for unusual patterns that are characteristic of arcing. They are able to distinguish between normal electrical activity and the telltale signs of an arc fault. When an arc fault is detected, the AFCI breaker quickly trips, interrupting the flow of electricity and preventing the arc from escalating into a fire. There are two main types of AFCI breakers: branch circuit AFCI breakers and combination AFCI breakers. Branch circuit AFCI breakers are designed to protect against arc faults in branch circuits, which are the circuits that supply power to outlets and lighting fixtures. Combination AFCI breakers, on the other hand, provide both branch circuit and feeder circuit protection. Feeder circuits are the circuits that supply power to branch circuits. Combination AFCI breakers are generally considered to provide more comprehensive protection against arc faults. AFCI breakers are now required by electrical codes in many areas for new construction and renovations, particularly in bedrooms and other areas where arc faults are more likely to occur. These requirements reflect the growing recognition of the importance of arc fault protection in preventing electrical fires. The question of whether an AFCI breaker will provide protection on old knob and tube wiring where the polarity has been compromised throughout two bedrooms is crucial for ensuring electrical safety. Firstly, it's important to understand that while AFCI breakers offer a significant advancement in electrical fire prevention, they are not a panacea for all wiring issues. AFCI breakers are designed to detect arc faults, which are dangerous electrical discharges caused by damaged, deteriorated, or otherwise compromised wiring. However, they are not specifically designed to correct or protect against compromised polarity. Secondly, compromised polarity, where the hot and neutral wires are reversed, presents its own set of risks. This condition can lead to electrical shock hazards and can interfere with the proper operation of certain electrical devices. While an AFCI breaker might still detect an arc fault that occurs in a circuit with compromised polarity, it will not correct the underlying polarity issue. The AFCI breaker will only trip if it detects an arc fault, regardless of whether the polarity is correct or not. Thirdly, knob and tube wiring, due to its age and construction, is inherently more susceptible to damage and deterioration. The insulation on knob and tube wiring can become brittle and cracked over time, increasing the risk of short circuits and arc faults. Additionally, knob and tube wiring typically lacks a grounding conductor, which further increases the risk of electrical shock. Given these factors, the presence of compromised polarity in old knob and tube wiring presents a complex safety challenge. While an AFCI breaker might provide some level of protection against arc faults, it will not address the underlying polarity issue or the inherent risks associated with knob and tube wiring. In this situation, the primary concern should be to address the compromised polarity and the overall condition of the knob and tube wiring. A qualified electrician should be consulted to inspect the wiring and determine the appropriate course of action. This may involve rewiring the affected circuits to correct the polarity issue, replacing the knob and tube wiring with modern wiring, or implementing other safety measures to mitigate the risks. Relying solely on an AFCI breaker to protect against the hazards of compromised polarity and old knob and tube wiring is not a recommended approach. While AFCI breakers can provide an additional layer of protection against arc faults, they should not be considered a substitute for proper wiring and electrical safety practices. In summary, while an AFCI breaker might trip in response to an arc fault in a circuit with compromised polarity and old knob and tube wiring, it will not correct the underlying polarity issue or address the inherent risks associated with knob and tube wiring. A qualified electrician should be consulted to inspect the wiring and determine the appropriate course of action to ensure electrical safety. Therefore, the answer is no. The compromised polarity needs to be addressed, and the old knob and tube wiring needs to be evaluated by a qualified electrician.